You are, I mean, you will be bored with the slides anyway.
Today, Arinda, you should change your room basically.
Why?
Why? Because why you are here?
I am in my regular.
No, see, this is essentially every year we have to give the roundup, na? That's precisely. But I don't know how many people will log in.
The program is live now, so okay. Yeah. So we'll start at sharp at 10:30.
All right.
Morning.
Good morning, Dr. Mohan.
Morning to everyone. Nice to see you.
Yeah. Same.
A very good morning to all of you. Today we are celebrating our Institute Day at the National Institute of Biomedical Genomics. As part of the celebrations, we have a full day program to do. To start with, I request our NIBMG choir to initiate the celebrations with an invocation song. I would now request our director, Professor Orindom Moitro, to kindly deliver.
Many thanks, Moa. Let me share my slide. Okay, I hope it's visible. So good morning and greetings from NIBMG. It's a rare privilege and honor to welcome you all, the guests, the distinguished speakers, and the members of the NIBMG family to this Institute Day celebrations of the National Institute of Biomedical Genomics in the year 2022. If I delve a little back into history, the institute was established by an approval of the Union Cabinet of Government of India way back in 2009 on this day. But prior to that, why was this institute set up? So when in the early part of the decade, this century, when this genomics and global health report came up in 2004, it identified genomics as one of the powerful methods of affecting, creating improvements in public health, especially in developing countries. And at that time, India was undergoing many changes and many economic, social, and other kind of changes, which will also which also is continuing to affect the health of the national health. Given this backdrop, two very important visionaries. One is our founder, Professor Parthipati Majumdar, and the other is Dr. M.K. Bhan, who was the secretary of the Department of Biotechnology at that time. They both got together and they set up this institute of National Institute in Kalyani. It's an autonomous institute under the aegis of Department of Biotechnology. So that's how the journey started, and I was a little fortunate in having a kind of a ringside view of the exciting things that unfolded over the last 10 years. So the institute has been set up as an exclusive organization to conduct and promote cutting-edge research in biomedical genomics, to practice and to promote research on biomedical genomics for current and future medical relevance of India. Its aim is to provide basic research evidence using the biomedical genomic approaches for improvement of public health and to establish state-of-the-art infrastructure for various, not only genomics, but multi-omics analysis with the explicit goal of improving public health. So public health has been a bird's eye view target for all the programs of National Institute of Biomedical Genomics, and I'm happy to say that it continues till date in the same way. The other objectives were to seed research, education, and translation and service networks, and you will see how we have progressed on those lines, especially over the last few years, to anchor young talent and through various postgraduate courses, build capacity, and undertake PhD courses and training programs in medical biotechnology, human genetics, molecular and genetic epidemiology, for promotion of genetics-based healthcare. And tied up to this is the academic program of the institute, which will be talked about later on during the information will be provided by my colleague, Professor Anupam Basu, who is the associate director. To enable, and finally, to enable better understanding of medical biotechnologies to permit faster but more discriminating methods for healthcare providers. So this is the objectives of NIBMG. Whatever NIBMG does basically is rooted in these the original objectives which the institute was set up. So we have 4 different areas of work. I mean, the first one and the most populated one is cancer, as you all know. In cancer genomics, we are looking at the major cancer problems in the country, in the subcontinent. And we are, of course, working on oral cancer, the most predominant cancer in men in India, and as well as cervical and breast cancer, the predominant cancers in women. And also we are taking on newer cancer types of the last few years, had a lot of success with it in terms of pancreatic cancer. So the cancer program in NIBMG started off parallelly with in a powerful mode with the participation in the International Cancer Genome Consortium project I did not say much more about this. This is talked about a lot. We have generated lots of data, made major findings on oral cancer, particularly gingivobuccal oral cancer, which is the most predominant type of oral cancer in India. And we have identified somatic mutational signatures and many other things, and we have already contributed to the ICGC in terms of the database that is available to the community and the public. And also the last major publication was a joint publication of the entire consortium on all the genomes, on whole genomes of all cancer types that the consortium worked on. We are also engaging with, in addition to international engagement, we are working with the institutes in and around us, particularly Indian Statistical Institute, Tata Medical Center, CSIR, IICB, Bose Institute, and IISER in Kalyani. And we are actually engaging with them in what we call as the systems medicine cluster, where you're using oral and cervical cancer as exemplars to enable deeper understanding of diseases at the level of biological systems, with the objective that this will lead to accelerated treatment and management of these diseases. Some of the major achievements of the last year, I am not going back in the what we achieved. We achieved a lot, but in the last year in particular, we came up with this database of exhaustive database of genomic variants of oral cancer based on primarily on our findings on 220 patients whole genome exome sequencing that was undertaken from the ICGC. It's called DBGenVoc, and it's made available to the community and the public. And so this is one of our big achievements last year. And in addition to that, we have continued to doing what we were doing earlier, which is cataloging, deeper cataloging of the genomic, epigenomic, and transcriptomic alterations of precancer and frank oral cancer. Emergence identified that stem cell heterogeneity in oral cancer through population transitions that are happening. We also found interesting information on cervical cancer, where we found heterogeneity among HPV-16 positive cervical cancer, and found relevance of crosstalk between coding and non-coding RNA genes in HPV-16 positive cervical cancer, which can have interesting inputs for therapeutics and prognostic targets. We have understood in breast cancer how JMJD6 potentiates TAM insensitivity in ER-positive breast cancer patients. And in pancreatic cancer, we had generated substantial information in terms of identifying key coding and non-coding genes, identifying deregulated RNA binding proteins, and studying the interference of single nucleotide polymorphisms with miRNA mediated gene regulation. So these are some of the major findings on this group from the last 1 year. Moving on to infectious diseases, here we have been working on intracellular protozoan parasites, sepsis, tuberculosis, and viral infections. So in this, over the last year, we have found global gene expression changes which are induced by interferon lambda 3 and lambda 4 in M1 and M2 monocyte-derived macrophages. We have identified potential role of interleukin 6 in NETosis and immunothrombosis in severe COVID-19. Host genomic factors of tuberculosis susceptibility has been a very important area where we have been able to shed some important information and shed a lot of light. We have found correlation of genomic correlates with various immunological markers in tuberculosis. And we are at this present moment, we are looking at functional validation of these genomic correlates using cellular models. In complex disease research, we work primarily on disorders with sensory neurodegeneration. We had been working for a long time on non-alcoholic fatty liver disease. It's a prominent area where our work has led a lot of generation of important information in biomedical genomics. We work on autoimmune skin disorders and diabetic complications, and finally preterm birth. Now, in the last year, in addition to what we had been doing, we had very important insights on the developmental glaucoma spectrum, where we investigated the role of WT1. We found a novel association of a particular genic region with primary angle closure glaucoma. And also found information on risk loci in narrow angle individuals. and functional characterization of the mutations in DES and LMNA causal to rare muscular disorder in genes were being carried out. In terms of the microbiome, we identify in preterm birth, we identified composition and diversity of the vaginal microbiome. For the first time in preterm birth in North Indian mothers, we also found functional insights in understanding the role of vaginal dysbiosis in augmenting preterm birth. And very important results on genomic and transcriptomic signatures of non-alcoholic fatty liver disease were published. The preterm birth program, which NIBMG participates in, is fueled by a participation in a large cohort called the GARB-INI cohort. It's part of the Grand Challenge program on preterm birth funded by the Department of Biotechnology. It's spearheaded by THSTI in Faridabad. And so it's a cohort, a prospective cohort of mothers are being recruited, and this cohort is being managed by THSTI and clinical research and other aspects. And NIBMG is partnering in this particular cohort and the study by analyzing the genomic and the epigenomic marks of risk for preterm birth. The other members are various hospitals like the Gurugram Civil Hospital, which is the major site. We found in this preterm birth, we are working on DNA methylation, and we are just temporal variants in DNA methylation in mothers during pregnancy. We have just completed a GWAS, a major GWAS on 6,000 mothers in this cohort, and we are looking at association with the maternal genetic risk loci with preterm birth. Looking at the other thematic area which we engage a lot, and it's one of our core strengths, is the statistical and computational genomics domain, where we look at population structure, we look at variation and human evolution, we work on disease susceptibility and response to drugs and vaccines. And one of the major programs in this cohort, which is a partnership of some of our faculty members with in the National Supercomputing Mission and other such large initiatives, where we are trying to develop a fast, flexible, high-performance computing framework to accelerate NGS omics data analysis. In particular, we're looking up to speed up data processing to GPU HPC compatible IO minimizations and rendering analytical flexibility and easy access through web-based frameworks. So there are multiple benefits for the outcomes of this particular study and the project. And right now, a tool called Map Insights has been developed that is essentially facilitating quality control analysis of sequence alignment files, as a lot of next generation sequencing is carried out by NIBMG and that is and other in the community. So this outputs of this project are very useful for optimization of computing framework. There is a development of tools called the genome test, which integrates knowledge from pathways, gene expression, and EQTLs into analysis of GWAS datasets. So this is a very important tool, and that right now the plans are to make it available and so being used widely. There is significant progress towards automation in silico identification of causal genes and mechanisms from GWAS and related studies. Gene environment interactions in complex states are being investigated, and some results have been obtained based on the UK Biobank cohort dataset. And of course, there has been substantial information published from our group from NIBMG on the insights into the demographic history of Asia from common ancestry and admixture in the genomic landscape of present-day Australo-Asiatic speakers. So one of the major programs in the population genomics area is the Genome India project, in which NIBMG is participating and playing a leading role as one of the major centers who are collecting samples, storing, sequencing, and analyzing them. So this project has been undertaken with the view that India is a diverse population. There are about 1.3 billion people, more than 400 tribal and 4,000 castes and subcastes. There are 4 language families, 461 languages, and 25 scripts. to capture this diversity and to understand the underlying population genetic variation, this project has been undertaken. It's a multi-center program all over India, and this program is aimed at addressing the global problem of Eurocentricity in studies of human genetics world over. The idea is the catalog of human genomic variations with special reference to India that will be generated by this project will be a very useful resource for further studies on genetics and for disease research. We have a flagship project, and our flagship project is on integrating multi-omics data using big data analytics to infer optimal life course trajectories for management of non-communicable diseases. We have started a couple of years back with cervical cancer as an exemplar, but the idea is that using this cervical cancer after generating some proof of concept views, we would also expand our portfolio and include other NCDs. It is based on a very exciting tenet that global emerging views that the disease is the hallmark of an adverse life course trajectory, which is modulated by inherited genomic factors and life exposures that altered the epigenome. And the whole purpose of this project is to look at these life course trajectories using biological variables derived by minimally invasive procedures, and then look for trajectory perturbations which can predict susceptibility and progression of disease using artificial algorithms, using artificial intelligence methods on longitudinal multi-omics and multi-dimensional data. So this project is very important to us, and we hope in the next 50 years, I mean, we would actually like to expand this, and this will contribute substantially the findings of similar studies which we would hope to launch on multiple non-communicable diseases to reduce the public health burden nationally. We have a cohort, the Kalyani cohort study, that was the brainchild of Professor Majumdar, and that was initiated at the early days of the institute's establishment itself. That cohort is now a 40,000 individual strong cohort drawn from villages in and around this peri-urban region called Kalyani, where the institute is located. This cohort is a very useful platform for long-term perspective, basic and translational studies on natural histories of diseases and genomics-driven biomedical studies. So we have a team of trained field investigators who collect data from the study participants and collect biospecimens, and then all the data and the biospecimen analysis results are stored in appropriate databases, which can be used for launching further studies using this cohort as a platform. So presently both the NIBMG's flagship project and the Genome India program are using this cohort as for the investigations. The last couple of years has been tremendously disruptive globally and India and in India as well. And that's because of the effect of the pandemic of COVID-19. I do not need to go into the details of it, but I'm very happy to say that during this entire course of pandemic, NIBMG did not shut down. NIBMG tried to maintain its doors open, and NIBMG from day one started to work on the ways that it felt it could contribute to tackling and understanding the pandemic. So way back in 2020, we generated the first sequence, whole genome sequences of the SARS-CoV-2 from infected individuals from the Eastern India, laid on to and then coordinated with the other autonomous institutes of DBT with support from DBT. We actually launched the first 1,000 genome sequences on SARS-CoV-2 from India, from different regions of India at different time points of the pandemic. And then finally, that showed a proof of concept, and based on that, the government of India has now from last year launched this powerful systematic national genome sequencing surveillance of SARS-CoV-2 called INSACOG, Indian SARS-CoV-2 Genomics Consortium. In this, NIBMG is playing a leading role in it's the largest genome sequencing center among these 52 sequencing laboratories that are right now participating, and is one of the 10 course laboratories which are actually helping other centers to come up and contribute to this sequencing efforts in this consortium. It's particularly sequencing samples from infected individuals from West Bengal and the entire Northeast. And till date, we have about 25,000 whole viral genomes of SARS-CoV-2 has been sequenced by NIBMG and made rapidly available in public databases like GISAID so that the community can use the information for drawing inferences on the pandemic. We have also come up with a portal. It's a NIBMG data portal, which has been housed from the NIBMG on behalf of the entire INSACOG, where all the information about the sample sequenced and the states covered and other kind of information are provided. And in real time, there is analysis of circulating variants of concern of the data from entire India, which is collated. And that is a very useful tool for the community to understand and the public health agencies to understand how the pandemic is progressing. And we hope to continue this effort, not only for SARS-CoV-2, but use this as a template for sustained genome sequencing surveillance of all emerging pathogens which can reach threatening proportions to cause a large-scale epidemic or pandemic in near future. Coming to the international program, so recently in December, NIBMG received BRICS funding for BRICS proposal. This is a collaborative network proposal on SARS-CoV-2 network for genome sequencing surveillance in all the BRICS countries of Brazil, Russia, India, China, and South Africa. And NIBMG is the leading institute from India, which is coordinating in this BRICS proposal. And other collaborating institutes are from National Laboratory for Scientific Computation from Brazil, Skolkovo Institute of Science and Technology, Russia, Beijing Institute of Genomics from China, and University of KwaZulu-Natal, South Africa. Tulio de Oliveira was a well-known name, and he is the international coordinator of our network proposal. We aim to increase access to genomic methods, and we also want to use the information that we generate in sequencing to trace SARS-CoV-2 introductions, identify community transmissions, and use this to characterize and control local outbreaks. And use the knowledge generated from the sequence data to improve diagnostics and therapeutics, and to capacitate BRICS scientists on the production and analysis of SARS-CoV-2 genomic data. Other very important international collaborations, NIBMG is very proud to say that it's a member of the Asian Immune Diversity Atlas, which is spearheaded by Genome Institute of Singapore, and there is other participating institutes of Samsung Genomics Institute of South Korea, Riken Japan, and many other places. Now, this is funded by the Chan Zuckerberg Initiative, the seed grant, and this is the first CZI funding in biology that in India has been received. And we hope to repeat this success very soon with multiple such similar initiatives. And NIBMG has participated successfully in the Genome Asia 100K program, where 100,000 Asian individual genomes were sequenced and analyzed. NIBMG is participating in Human Cell Atlas. Our founder director, Professor Partha Majumdar, is actually a member of the Human Cell Atlas. And also recently he has been elected to the, very happy to say that he has been elected to the executive committee of the International Common Disease Alliance. So this has enabled our participation in the Human Cell Atlas and our kickstarting our single cell transcriptomic and genomic approaches. And we hope that this will also help us to participate visibly and substantially in the ICDA, which aims to improve prevention, diagnosis, and treatment of common diseases by accelerating discovery from genetic maps to biological mechanisms. Over the last 1 year, although it was marked by disruptions from the second wave, and then towards the end there were disruptions caused by the further emergence of the Omicron, we still had 48 publications in major scientific journals, peer-reviewed journals. We had launched the DBGenVoc. We established, so there were multiple publications which were reported establishment of novel buccal mucosal cancer cell lines, identification of a meta signature of RNA binding proteins in pancreatic cancer, as we said, vaginal microbiome signatures, and look NFLD and other diseases as I mentioned earlier. So it has been, and we hope that in the next year onwards we will be able to surpass this, and we'll be able to really come up with some visible information that will be very useful for public health management. The NIBMG is proud to house the central core of the National Genomics Core that is funded by Department of Biotechnology, Government of India. The aim of this core is to provide access to the high-end cutting-edge technology platforms of genomics, essentially sequencing and microarray and similar approaches and data analysis of these genomic data generated, and provide expertise and consultations for undertaking such studies for both academia and industry. And NIBMG has a history of sharing its facilities since its days of its setup of its laboratory, and we have expanded now with the National Genomics Core, and these services are being provided by our considerable firepowered laboratories, which makes us a formidable genome sequencing center. So we are providing access for various kind of applications. Our database, our progress and generation of data has been fairly uninterrupted. We managed to continue to do that even in the face of the last 2 years when the pandemic raged. And if you see that we have accessed almost every state and every region of India, people are coming to us and accessing our genomic services and taking our help. There are various other new facilities that have also come up, including the zebrafish facility, the newly set up proteomics facility, and the confocal microscopic facility. These are primarily aimed to add depth to our genomic discoveries and our genomic studies, as well as provide platforms for taking up multi-omics based deep studies on various diseases that we work on. There are more interesting and exciting news to follow on this, and again, my colleague Professor Anupam Basu will talk a little more on these. We have a genetic services unit located in the tertiary healthcare facility in IBGMER Kolkata, and we provide offer genetic tests for 45 diseases. We have been able to provide to about 1,800 individuals. So and these are from hospitals in different regions of Kolkata primarily, and also in other districts in West Bengal. And this is something that we are trying to expand, and we hope to sustain and provide this benefit to patients. We continued our outreach activities primarily online, but also some physical events. So we had our Foundation Day celebrations last year, where Dr. Shiv Shareen was the chief guest, and delivered the Foundation Day lecture. We also had felicitation of Professor Soumitra Das on his 60th birthday by hosting a symposium on molecular dissection of human diseases, where very distinguished speakers gave talks, and we had a fantastic science day that day. We also participated in the India International Science Festival 2021 in Goa in person, and I and many of our colleagues, and particularly some of our younger colleagues, actually were very excited, and due to their motivation, we could actually go and participate there. Our exhibits and stalls attracted a very large volume of young minds. And ultimately, during the last day of the festival, we are awarded a prize for the most well-conceptualized stall in IISF by the DGCSIR, Professor Shekhar Mande. We have a program called Science Setu, through which our faculty members deliver talks on specific areas for students of UG and PG colleges, network of colleges that are tied up to us, and we are fairly consistent in doing this as a celebration of the Azadi Ka Amrit Mahotsav for Sashakt Bharat and Vigyan Se Vikas Pradyogiki Se Pragati. we observed the World Cancer Day when two of our younger colleagues, Dr. Ankita Chatterjee and Ms. Abarna Sinha, they delivered talks on oral and cervical cancer on 4th February online. NIBMG has a rich tradition of organizing workshops to disseminate expertise and training for the idea of building capacities in biomedical genomics. During the pandemic, that got affected, of course. But last year, we could do two major workshops. The first one was done in January. It's an online mode where we could actually do both experimental and analytical methods exhaustively on single cell transcriptomics in collaboration with MIT Boston. And this was a very proud participation where our younger colleagues like postdoctoral researchers and senior PhD students actually contributed a lot and undertook disseminated direct teaching on some of these topics along with members from MIT. We also held a hands-on workshop on molecular methods in diagnostic microbial biology. This is primarily for clinicians. This was done in collaboration with IPGMER in December, and it attracted a lot of participation and people were very excited. The clinicians felt that we should do more such workshops more often, and we hope that with the dissuasion of the pandemic, we'll be able to do many more such workshops on multiple areas as we had been doing in the past. If I look into the future, so based on some of our discussions that we had and in the institute, we want to go on specific directions now. Over the last 10 years, we have generated information, we have findings, but if we look into the next 10 years or more, in cancer genomics, we would actually like to go from patient cohort to precision treatment. And to do that, we would actually like to use cross-sectional to longitudinal data generation on the major cancer types that we are studying. And we have also already initiated single cell studies on some of the cancer types and other diseases. So we would like to expand those to look at multi-omics, use multi-omics single cell approaches to understand this kind of understand the complexities of various cancers. We would also like to go for discover diagnostic and prognostic biomarkers using genomic signatures, exosomal and other cell-free markers, and functional validation of the leads would be followed up with CRISPR-based genome editing. For infectious diseases, we are moving from disease biology to molecular determinants of disease outcome, where molecular determinants of clinical phenotypes of infections would be identified, deep investigation of host pathogen interactions would be undertaken, and the host microbiome crosstalk will be delineated. In complex diseases, we are moving from discovery to validation of the genomic and epigenomic alterations that we have identified, where we will understand better the genetic and epigenetic heterogeneity and explore combined effects of human genome and resident microbiome, followed up by a deeper functional validation in other models to understand the impact of the discoveries in the genome and epigenome that we come up with. In statistical genomics, we'll be tackling the challenges in data integration, develop methods for analysis of multi-omics data, develop artificial intelligence, develop cancer variant databases more, and integrate prior knowledge for identification of the causal variants. So I will take a little more time in welcoming our new members to our family. Dr. Arvind Korwar, who has done his postdoctoral research in CSIR, NCL Pune, NTU Singapore, and Penn State University and North Carolina University, has joined us as assistant professor. His focus is on mass spectrometry-based proteomics and metabolomic approaches to chronic inflammatory diseases, and he is also interested to use these methods to understand metabolic reprogramming, remodeling during oral cancer progression. And we have also been joined by Dr. P.V. Raghavendra. He has done his postdoctoral from Michigan State University and Roberts Research Institute, London, Canada. He's working on human disease models simulation studies, stem cells, and CAR T cell translation therapies. He's particularly interested in lung diseases like COPD. Young members joined last year in various stages. Some of them have already started working a lot. I mean, so we have Dr. Debanjan Mukhopadhyay, who has done his postdoctoral research from University of California, Davis, and he's looking into functional characterization of SARS-CoV-2 accessory proteins, understanding role of non-immune cells in autonomous innate immunity against intracellular pathogen infection. Dr. Anup Majumdar has done his postdoctoral research in University of California, San Diego, and Los Angeles, and he is working on identification of host immunogenic determinants of COVID-19 disease among mild, moderate, and severely affected patients, and investigating the role of enhancer RNAs in pancreatic cancer. Dr. Moa Maulik has joined in very recently. She has done her postdoctoral research in CSIR, IGIB, and IISER, Kolkata. She's working on investigating the role of gap junction intracellular communication channel proteins in neurodegeneration and neuroprotection. So we also have Dr. Anusua Chakraborty, who joined as the DST Inspire Faculty Fellow, and she has done her doctoral research from Friedrich-Schiller University, Germany, and is working right now in NIBMG on sex differences in the genetic architecture of human complex diseases. Two of us have also joined last year, my colleague and very close friend, that Professor Anupam Basu from University of Burdwan, and yours truly have joined as associate directors of NIBMG last year. And we hope to contribute significantly towards further efforts and future initiatives of NIBMG and enable NIBMG to reach significant heights in biomedical genomics research globally. I would end with thanking many people. So my gratitude and my sincere thanks to my predecessors in directors of NIBMG, particularly our founding director, Professor Partha Majumdar, who still engages with us a lot and participates and contributes significantly to the research in NIBMG. And we always look up to his advice for our research. He established the institute in a unbelievably rapid manner, in a situation where things were not easy to establish. And from there, I am sure he would be happy to see the way the institute is progressing. Professor Sharmila Sengupta took over from Professor Partha Majumdar and was taking charge at a very difficult time of the institute, when the institute was transitioning from its temporary old campus in the nearby TB sanatorium to the present new campus of the institute. And she ensured that the transition could happen with minimum pains, and the institute was up on its feet in the new campus immediately after transition. Professor Soumitra Das was our last director. He just left us to ISC in January end. Of course, that was physically, but he remains with us, engages with us, and we collaborate a lot on many of the research that we do together. And he was responsible for expanding the institute's newer facilities, for adding depth to our genomic research, expanding the campus, and in particular spearheading nationally the genome sequencing efforts and genomic surveillance of SARS-CoV-2. Also stand on the shoulder of my colleagues from faculty, staff, students, postdoctoral researchers, and laboratory personnel who work day in and day out for the success of the institute. Very thankful, and I express my sincere gratitude to all of them in this occasion. So with this, I end saying that our genome clock keeps on ticking, did not stop during the pandemic, and I hope it will never stop. Thank you very much. Over to Moa.
Thank you, Professor, for the warm welcome, for sharing with us a few of major initiatives and achievements. So now I would like to request our Associate Director, Professor Basu, to kindly delve into it. Professor Basu, please.
Thank you, Moha, and lots of thanks to Dr. Arindam. A very good morning, all of you. Welcome, all of you. Very sincere thanks to everyone participating and viewing this program today live. It's my good privilege to welcome you, Professor Mohan, to this occasion. You have redefined the diabetes treatment and research in India. I express my thanks for providing your time, and later we'll be waiting to listen yourself. It's my also pleasure to thank Professor Bertha Maria Coopers, Professor Maria from the Department of Human Genetics and Faculty of Medicine. We will be listening her in the latter evening part of this program today. It is a great pleasure to have with us Professor Soumitra Das. Professor Das, entire NIBMG family is waiting to get you your warm again. Today it is a very honor, privileged moment for us, for me particularly, as I am speaking before you to this auspicious occasion and this esteemed institute position of the associate director to say something of you. Dr. Arindam Moito, our editor in charge, already explained you the journey and success. So my role is to enlighten you with some future planning and scope for your brainstorming. As Professor Moitra already pointed out that we have two associate directors join this institute. So our role to define the future and to help this institute to define future and grow more. At the vision of the Professor Partho Majumdar, our beloved Parthoda. After joining this institute, I asked Parthoda whether the mandate of this institute should be with the National Health Genome Research Institute, USA, and also other global institute. His answer was assertive. So, friends, ladies and gentlemen, our goal is to go there. We have slowly started our progress. We have a global landmark in this institute. In this occasion, I'm taking this opportunity to address some of the future scope based on our faculty for the entire research work did last 10 years and more. So how this strength can be utilized for the future progress and expansion. So I also requesting our advisor, DBT and Scientific Advisory Committee for their guidance to shape up the future direction. I also remind you, our advisory committee proposed earlier that we should expand the single gene disorder and rare genetic disorders along with complex disorders. I'm happy to share with you, we have already started work on single gene disorder like thalassemia. We have already opened up our work on rare genetic disorders, multifactorial traits like Alzheimer and others, as per our strength of our scientists. Based on the current strength, stronghold of our research, our background on the expansion of ongoing research areas, we can emphasize some of the points that need further discussion and finalization for future expansion. I can mention some of them. Expanding of cancer genomics research program from oral, cervical, and breast cancer to gastric cancer, pancreatic cancer, already achieving it, to the other cancer of regional interest, show that can be much more focused research approach for marker discovery, rapid diagnostics, and others. We're already working on the single cell analysis of the different like oral cancer. So that has to be diversified and expand in the single cell research or patient level from all stages of different cancer like breast, pancreatic and other cancer, and cellular dissection of the immunogenetically aspect. In the area of complex disorder, delineating the genetic heterogeneity in the developmental glaucoma, neuromuscular spectrum of disorder, also along with diabetes, cardiovascular disease can be expanded, and investigating the role of the modified genes in the developmental regulatory network and also multi-omics approach is a background of the genomic signatures. Now, to translating our genomic findings into gene panel and rapid diagnostic methods should also be developed in the current futures for the both cancer research as well as the multiplex multifactorial disorder also. We have just passed or passing also COVID. Now COVID has showed new way of thinking of the infectious disease. So our infectious disease, in the light of the host genome signature, we can identify start with our already background information of disease like tuberculosis and sepsis and others. We have to think on it. Post-genomic landscape and skin-gut metagenomic axis in the development of autoimmune skin disorders in the human and also involvement of the immunogenetics. Establishment of patient-derived organoids for modeling disease heterogeneity and treating the precision medicine and the research. We have already come up with the facilities. So now you have to expansion of facilities in the software manner, how these facilities can be expanded more for global or national utilization and our utilization. We have the start of data center and computational genomics data analytics in the informatics facilities. In this occasion, I'm requesting DBT and Government of India, NIBMG may be the good nodal institute for hosting, curating genomics as well as multi-omics database. In this context, I like to remind you, most of the time we can get reference from American College of Medicine Genetics Genomics ACMG guidelines, but it already been established that our gene variants are not always same with the Western population. Thus, there is the need of comprehensive database of medical genetics variants catalog for Indian population. If we have been given tasks as per our both hard work and expertise scientists, we can deliver this for our nation. Coming to we have already developed our proteomics facility now. Multi-omics approach really possible here at NIBMG. So our faculty members are already started their work to testing their hypothesis in multi-omics approach. We have already started a geographic facility that is already being utilized for validating genomics lead into the functional pathway. That facility can be utilized by the other institute like also that. With the help of ISAR Kolkata, DBT, CIMAC project, a state-of-art joint ISAR NIBMG animal health facility already been established. Right now, both the ISAR and NIBMG working on it to how this facility can be purposefully utilized. We are already currently active state for starting the basal or establishing the basal 3 facility for infectious disease biology research in depth. Friends, our vision on Professor Partha Majumdar has a vision that the building of the NIBMG has a global or national need also. With the direction, we have already established our building, and the part of this building, as per his vision, we are looking for the startup and buy incubation. So accordingly, we are requesting all of you, if you have the urge and we are thinking for startup research and genomics-based solution with industrial footholding, you can think NIBMG is the correct incubating area for you for industrial delivery. Some of the areas as per preference, not limited, you can think on that. Clinical exome, diagnosis-based approach, development of gene panel of both human genomics and metagenomics origin for effective screening of human disease, development of probiotics modulators, human microbiome in Indian population based and their genetic architectures, preparation of the chip panel for genomic and disease discovery approach, and any other areas that can fit the mandate and vision of the NIBMG. Shortly, we will start for this purpose to have the bioincubation facility here in NIBMG. Now, Government of India already promoting the revenue generation model in the Autonomous Institute also. So we have to think for that. We have already started state-of-art genomic facility, getting revenue from the different institute by our service. We can utilize our proteomics facility for commercially to generate the revenue, as well as the service can be approached to other institute and academic body also. It can be encourage us, faculty members of ours can engage in consultancy service in genomics and other areas for that institute. We have the academic program. We have the academic institute. Slowly we are growing. We have a long way to go. After joining in this institute, it was a fast track to cater the academic program and expansion. We are already working in this direction, expanding our network with the different institutes of India. We are encouraging move with the different leading medical institutes of India. So we will be pushing this direction. Already MU with the AIIMS Kolkata are on the active state. We'll be trying to our best. I am taking this opportunity to also request Dr. Mohan for your help and support with the collaboration of the Institute for Diabetes Research, because some of our faculty members are already working in this area. We have the PhD program that is being under the control of the Regional Center for Biotechnology. We are expanding this program. We are redefining this program so our student can best practice, best motivation can get from this institute. We have integrated MS PhD program for biomedical genomics. So students, we have already talked with you. We got your suggestion. We are working on it. So slowly, you'll be getting the change of the system. If it's need, we can do some in-depth variants in their program. Personally, just 3 months back, I have taken the responsibility of associate director. Thus, I am new in this family. So this is my advantage to see the things and the perspective in neutral manner and scope like that. In this opportunity, I'd like to remind you, all of us, in this context, the functional validation of approach in this thing, I like to remind all of us, we should not undermine the value of investigation of genetic signature and structural genomics of our own population. What should be the translational research of the Institute of Mandatory Genomic Research? Again, we need not to in-depth thinking. We have to in-depth thinking and brainstorming of scientists involving themselves. What is the scope of the functional genomics and structural genomics? Accordingly, I place before all to have the brainstorming based on the expertise of our in-house faculty members and our advisor of the Scientific Advisory Committee. At present, all the degree institutes on the crossroad. In this occasion, I like to just have the statement of my own feelings to share with you. In India, we have the institute like CCMB, NCCS, and we also NIBMG. So in this context, we have to understand the mandate of NIBMG. So putting this goal before you, to think before you, and your idea we can share with you, and our idea can share with you, all of you. I am ending my speech today. Thank you very much.
Thank you, Professor Basu, for your kind remarks. As Professor Basu mentioned, it's indeed a great pleasure and privilege to have our former director, Professor Soumitra Das, with us today on this occasion. I would now like to request Professor Das to kindly share his thoughts this Institute Day. Sir, please.
Sure. Namaskar. I'm very happy to be back with you guys. You know, it's a great honor and privilege every time I speak at the Institute Day at NIBMG. But it's definitely a different feeling coming in the second down when the first two batsmen, the opening batsmen, both Arindam and Anupam, has already strongly established the innings. So I don't have the pressure to introduce the institute or the faculty or the programs. So I am allowed to use attractive shots and entertain you. So, you know, it just looks like that we are coming out of the Hurricane COVID. And, you know, it just reminds me when we just came out of this Hurricane Fani and there was one more, it is important to look for the damage control. And certainly NIBMG is rightly poised with its all experience and expertise to contribute in the post-COVID era. And I was just thinking whether actually I can share my thoughts with the present team of NIBMG to think about it and see how we can actually reprogram and help better to the society. You know, the genomics is now immensely popular. And, you know, before that, sequencing was kind of, people used to sequence and think that that is some theoretical backwater and people can have the luxury to use the sequence whenever they need it. But never realized the importance of the sequence to this extent what we have experienced in last 2 years. So, last 2 years have actually showed us that how you can make sequencing hubs in different corners of the country. And I am again privileged to coordinate this INSACOG, which is now actually handling 52 centers all over India in different corners to cater the requirements of the genomic variants and identify early detection for the COVID variants that are emerging almost every month. So, there is a scope to contribute in a huge way in cashing the present popularity of the genomics and the encouragement from the government of India. I was just thinking that NIBMG can think of setting up a major infrastructure and a facility which will be connected not only with the sequencing but with the hospital network to cater the entire Eastern India, which NIBMG is already doing it, but we can think of making it more organized, more formalized, and expand its horizon a little bit more to really cater to this part of the country. During COVID, we have seen that how the COVID infection actually affected different individuals differently. When it is true, we have been looking for different variants and see that different variants are actually affecting different population differently. We need to really focus more on the genetic determinant or the host determinants and how they are actually responding to the viral infection. But most important at this stage is the post-COVID complications. I'm glad Dr. Mohan, finally we could get it. I've been trying to get Mohan in different meetings, committees, but was not successful. I'm very happy, Dr. Mohan, that you are joined today, and we are looking forward to hear from you on the precision diabetes. And it's actually it's a great thing for us, and I'm sure we'll be able to connect you with NIBMG and involve you. We need your guidance and your help and expertise to move forward. So coming back to these post-COVID complications in the patients, that is also differential in different patients. And if you really see it closely, it might be different in different population, in the state, in the country. So there is a huge scope for this network, if we can establish in the Eastern India, to have an organized way of studying the impact on the individuals in the post-COVID scenario. And is it possible that we can actually try to identify some disease? It's more a predisposition to a disease complications for a particular individuals. I'm sure Dr. Mohan will probably highlight the impact of COVID in the diabetic patient. But what is this importance? What is the impact on the cancer patients? What is the impact with the TB patient? What is the impact of a liver disease patient or a kidney failure or a kidney transplant patient? It's very, very important for the whole world to actually look into it. And I'm sure NIBMG is actually the right place to address such kind of questions. Having said that, I was just thinking we can actually encash our huge treasure of this Kalyani cohort, which is now it's time to make it more formalized, more organized. I mean, it's a huge effort from Parthoda, Anulavo, and others to maintain and build up this cohort of 20,000 or and an expanded situation. Is that possible that we can identify a subgroup within the cohort who are infected with COVID and try to see whether this patient cohort, I'm just saying, if they have some complications, because we have an access to these patients, is that possible that we can monitor longitudinally and try to assess the impact of the Hurricane COVID, as I was mentioning, or the impact of this virus or the viral proteins in a longitudinal manner? I think we can think of that. And for that, it is important, as Anupam was also mentioning, that we can link it with our local hospitals. Maybe AIMS and JNM can be involve more into it and try to see whether we can connect them and really explore and exploit this colony cohort to address the impact and assess the impact of the post-COVID patient. I was also thinking there is a scope, enough scope to expand the horizon of the GSU and the BMGU. You know, I have been trying and I tried my best, but I think because of the COVID, we were actually couldn't really do much in this sector. But there is a huge scope to project this GSU BMGU as a center for clinical genetics and involve more clinicians, focus more on the clinical applications in the the applications of the genetics and the genomics informations for the treatment and also the predisposition. You know, finally, you know, it is important to engage ourselves with the society, to connect ourselves to the society, and the best way with the expertise available at NIBMG. I think yesterday only I was just talking to Arindam that it is time to really exploit our expertise on the single cell sequencing, and the single cell genomics is the future. And that way we can actually tell that what are the problematic cells in a milieu of the other cells in a tumor, and can actually suggest the clinicians for a precision treatment regimen or a precision medicine for that purpose. And I think while we are actually stretching our horizon and expertise to this, maybe we should always keep it in mind that we can make use of our single cell genomics expertise, which is not really available to many places in India, in the country. So this is high time to use this for the national health. Now, and finally, I would like to highlight that NIBMG is also having a component for the translational work. So the signature that we have obtained, the leads that we have obtained, it is high time to think the present regimen, to think beyond this and try to see how we can actually take it to the bedside. And for that, what is important, we need to involve more Mohan into our team and try to see how we can actually use their experiences and expertise to come up and a new team for a translational research at the NIBMG. As Anupam and Arindam, both of them mentioned that NIBMG is now ready to house startups. And you know, that is something I just ignited but couldn't really initiate. But this is high time to initiate those startups, and those startups can actually take up the leads. And with the help of the involvement of the clinicians, I think that could be a better future for the institute. And definitely, I can see there is a scope for involvement of the industry people with a different kind of lookout, in a different kind of dream, so that we can try to marry our basic research with an industrial applications and try to see how we can strengthen our translational goal, what was originally conceived by Parthoda and Professor Bhan, that NIBMG will actually take the genomics from the bedside to the bedside. And that's basically, essentially, I'm sure with the new recruits, with the new facilities established, with the new students, more and more in numbers, the new initiative, the new beginning, the new dawn, the new administration, I'm sure with all the collective expertise and the wisdom, NIBMG will march ahead with a much brighter future. We are at the teenage, we're I think 13 years, and teenage has its own problems, adventures, and challenges. And this is high time to actually comprehend and use our experience for the last 12 years and try to see how actually we can shape up for a better future. Looks like I'm away from NIBMG for too long, but it's just more than a little more than 3 weeks. But you know, that's essentially NIBMG. I never knew that I am so much deep rooted with NIBMG emotionally and personally. It's very hard to uncouple, but definitely time will heal up. but I want to reassure you that I'll be always with you virtually, and whenever needed, I'll probably show up, and I will definitely extend all sorts of help, whatever possible in my any capacity, and to set up the vision and the mission that actually was conceived by Parthoda and now carried forward by all of you, Arindam, Anupam, and all the faculty members, the students, researchers, and more importantly, our advisors like Dr. Mohan. And this is really a time that we are actually looking at your experience, your expertise, to how to make our research endeavor into a real translational endeavor and really serve the society. With this, with all the best wishes and the love and affection and respect I got it from NIBMG, I'm not going to forget. It's not easy to forget. I don't want to forget. I'll remain with you. Thank you very much. Bye.
Thank you very much, sir, for joining us today, and thank you for the very encouraging words. So moving on, we'll now have the Institute Day lecture. I would like to request Dr. Onulabo Basu to kindly introduce our chief guest, Dr. V. Mohan, and welcome him for the Institute Day lecture.
All right. A very good morning to everybody, and welcome again to the NIBMG's Institute Day celebrations. It gives me immense pleasure to introduce Dr. V. Mohan, our chief guest today for the Institute Day lecture. Dr. Mohan has made excellence his habit. He's a real multifaceted personality, a clinician, a scientist, administrator, a capacity builder, a visionary who has built a world-class health system in India. Dr. Mohan is the chairman and the chief of diabetology at the Dr. Mohan's Diabetes Specialty Center at Chennai in South India. The center is an IDF Center of Excellence in Diabetes Care. Dr. Mohan oversees a chain of 50 diabetes centers across 8 states of India and has over 540,000 registered diabetes patients in his centers. Dr. Mohan is a prolific researcher. He is the president and director of the Madras Diabetes Research Foundation, which is Asia's largest standalone diabetes research center. His main research interests are in epidemiology of diabetes and its complications, genomics of diabetes, including monogenic diabetes and type 1 diabetes, fibrocalculus, pancreatic diabetes, and precision diabetes, about which we're going to listen very, very shortly. Dr. Mohan has close to 1,500 peer-reviewed publications, which this includes about 1,000 original articles, 344 review articles, and invited editorials, and more than 150 chapters to textbooks in diabetes. His research has attracted over 165,000 citations, and he has an amazing H index of 142. Dr. Mohan is ranked among the top 2% of scientists in the world by the Stanford University ranking, and is among the 0.01% of researchers in type 2 diabetes by expert scale. Dr. Mohan is also a passionate teacher. He has trained a large number of physicians and diabetologists in addition to nurses and educators. NIBMG has a long and close association with Dr. Mohan. He has been our guiding vision of our clinical research. He has been extremely helpful. Indeed, he has been very, very instrumental in setting up the BMGC, the Biomedical Genomics Center, which is now renamed as the BMGU, or the Biomedical Genomics Unit. This was set up to build a bridge between the clinician scientists and basic researchers, and for the scientific guidance of the center, Dr. Mohan also took up the responsibility of the first chairperson of the Scientific Advisory Committee of BMGC. He has now documented his experience in his autobiography, Making Excellence a Habit, The Secret to Building a World-Class Healthcare System in India, and it was published by Penguin India. And likewise, as he has made excellence his habit, the book is a bestseller. Dr. Mohan is, of course, very, very well decorated. He has received more than 200 awards, which includes the prestigious Dr. B.C. Roy National Award by the Medical Council of India and the B.R. Ambedkar Centenary Award, which is the highest award for biomedical research given by ICMR. He was conferred the Harold Rifkin Award by the American Diabetes Association, and he's, of course, the first Indian to receive this. He's also one of the few Indians to be conferred the FRS of the Royal Society of Edinburgh. For his extensive contribution to the field of diabetes in 2012, Dr. Mohan was awarded the Padma Shri by the Government of India. So please welcome Dr. Mohan for our Institute lecture.
Thank you very much, sir. I'll just get my slide. Can you see my slides? Can you see my slides, sir?
Yes, your slides are visible.
So thank you very much, Dr. Anlaba Basu, for that very kind introduction. I'm really thankful to my very good friend and colleague for many, many years, Fatma Majumdar. He has been an inspiration to me right through my career. And I must also, thank him for helping us to start a very small genomics facility at our center. He was there right from the start when we were getting the equipment. He had come as an expert committee member. But more than all that, I think one of the crowning achievements of his life would be setting up the NIBMG, because from an idea, almost from scratch, and starting in a small rented kind of a facility, to this institute, which can match any other genomics institute in the world, I think is no mean achievement. And I think this institute will stand as his legacy for generations to come. I would also like to thank him for the kind invitation to deliver this very prestigious Institute Day lecture. When I accepted it, I didn't realize what a great honor it was. Although any invitation from Partha was very difficult to say no, so I immediately said yes. But later on, I found the number of people who were sharing the invitation. It went round and virally, and a lot of people congratulating me. And I said, "What for? Hey, you're giving the Institute Day celebration lecture. Don't you realize how big it is?" And then I realized, of course, I knew it's big, but I didn't know it's this big. And so I'm totally humbled by Professor Arindam Maitra's presentation in cataloging all the work done by the NIBMG, and I feel very, very humbled. That's the one word that I can use. In fact, almost scared to give this lecture after listening to so much of work being done of a very, very, very high order. And so it's very humbling to know how small is the work that we all do. And thank you, Dr. Anupam Basu, for those kind words and for suggesting some areas of collaboration. And Professor Soumitra Das, I would like to apologize if I haven't been there earlier, but NIBMG is one of my dream institutions, and therefore it's my honor and my dream to come back and to see every year you're progressing so much in the institute that I would be delighted after this COVID thing has totally settled to come back once again and to see, sometimes it's like, going to a religious place and getting your batteries completely recharged. For me, science is my religion. And therefore, coming to NIBMG would be one of the, it can recharge my batteries for many more years to come. So I'm really looking forward to that. But one thing I just wanted to tell Professor Soumitra Das, as well as Arindam Maitra and Anupam Basu, you're repeatedly saying that NIBMG is, can cater to the eastern part of the country. I would actually say, no, this is wrong. You are a national institute. Why are you just thinking about eastern part of the India? Of course, eastern part of the India is important, but what about southern part, western part, northeastern part, northern part, central part? The whole of India is yours because you are a national institute, and there is no other such institute in the whole country. So don't forget poor people like us who are in the south and in other parts of the India as you expand your activities. And not only that, I think you're truly a global leader. You're not just a national institute, but an international institute from the kind of collaborations, not only in SARS-CoV, but all the other collaborations that we have listened to. And congratulations, Partho, for the every time we meet, there's some new award which you're getting at a very high level. Your work is, and the work of the institute is getting recognized nationally and internationally, and I'm not surprised at all of to how this is happening. So again, on that very humble note of being in the presence of giants, I'll try to share with you some little work, and I'm sure I'm glad that Professor Soumitra Das kept on talking about translational work. But that's exactly what I'm going to talk as a clinician. How we have tried to marry science and clinical medicine, and how small steps are being taken in that. So that's the title of my talk, that precision diabetes is now becoming a reality. And again, very humbly, we have put that. I'm not saying it's become a reality. We have, there's nothing more to go and so on. Baby steps are being taken, but I'll show you how even those baby steps definitely influence, the lives of people. And you're absolutely right that medical genomics has to have a translation. You have to have clinicians who tell you what their pain points are. And if you solve those pain points, you're not just publishing science and taking science to a higher level, but actually touching and improving the lives of people, and maybe even saving the lives of people. I have no conflict of interest to declare. Most of the funding comes from government agencies. I'm going to start with this particular question. In life, does one size fit all? You see, there's a little girl, she's wearing glasses which is far too big for her, and she should have been given a different size, isn't it? And look at this young boy. He's wearing his father's, dress and his father's shirt and father's shoes and father's tie. One day, of course, he'll get there, but we can't give this to him at this age. We have to, tailor make it to him. And so in life, when we don't do this, my question to you is, how can the same treatment be given to everyone with diabetes? Very often when a blood glucose level is elevated, we say you have diabetes, and then the treatment becomes one routine treatment. In fact, even up to 5 years ago, all the world guidelines, including the American Diabetes Association, the Indian guidelines and so on, said just give metformin to everyone and be done with it. And then after that, if it doesn't work, you try another one. If that doesn't work, try another one. I would say that's like taking a lottery ticket and then saying which one are you going to bet on, or a horse race. You go and then pick one horse and then you're going to bet on that. I think we should move on a little bit more in science when we, even as clinicians, when we treat any condition, and diabetes is no exception. If you look at the American Diabetes Association classification diabetes, this is the same, all over the world. The WHO also follows the same. We know that there are at least 4 types of diabetes, and within that there are so many types of diabetes. For example, there is type 1 diabetes, which itself is of 2 types, immune-mediated and idiopathic. Type 2 diabetes, which is actually a wasteful basket diagnosis, because if it's not one of the other types, you put it under type 2. And I'll show you how much work has gone on to subclassify type 2 diabetes. And then you have a whole list of conditions called other specific types, into which you can pack in at least 40 or 50 different types of diabetes. And many of them you can see has genetic defects of beta cell function, genetic defects of insulin action, other genetic syndromes. So genetics has already come into the classification. If you don't do genetics, if you don't collaborate, how are you even going to diagnose these conditions? You're going to say everybody is type 1 or type 2 and give them the same treatment, just like those 2 children were given. And of course, there are other conditions like gestational diabetes mellitus. And therefore, that brings us to the subject of precision diabetes or personalized diabetes. Now, this precision medicine is already taken shape. For example, if you give a very rough example, if you had to take a blood transfusion, we don't give the same blood to everyone, isn't it? There is A and B and O and AB group, and then there's positive and there's negative, and there are so many subclassifications of blood group. If you get the wrong blood group, you'll die. So that itself is precision medicine at its very rudimentary level, where you see what they have, which group they have before you transfuse blood. In every field, with hepatitis, when I was a young medical student, we were just taught it's jaundice and hepatitis. We didn't even know hepatitis A and B at that time, leave alone C or D or E or others. And today, without knowing the type of hepatitis, we don't even treat. Breast cancer was just breast cancer. We didn't have hormone positivity and triple negative and double negative and triple positive and so on. Each one having its own prognosis. The field of diabetes has been a little slow to start with, but now it's picking up speed. Now, first of all, let me tell you what's the difference between precision diabetes and personalized diabetes. Precision medicine or precision diabetes is a narrower concept. You just look at a gene and say, okay, this gene is there, you give this, or this environment is there, you give that. So it's actually based on science. And it's very good because you know precisely what you should be doing. Now, personalized medicine is a slightly broader concept because having then decided that based on this particular gene, you are going to give that to a particular person, you may find that the person's social context doesn't help you to give it. The computer tells you that you have to give X medicine to the patient, and the X medicine costs the patient 20,000 rupees, and the person cannot afford it. What do you do then? You have to adjust according to their social context. So there must be a plan B. And then the patient's preferences should be taken into account. The computer is telling you give him insulin or give her insulin. And the patient says, oh, my dead body, I will not take insulin. So what do? You have to find some alternative if there is an alternative. Sometimes there is no alternative. Okay. So when you do that, that becomes personalized medicine. So this is where I think a clinician comes in because we use the science, but then we have to modify it for the patient as well. Now, very recently, the American Diabetic Association and the European Association Study of Diabetes have started what's called as a Precision Medicine and Diabetes Initiative. It's a very large initiative where 250 scientists are working on different aspects of precision diabetes. Some are working on precision type 1 diabetes, some on type 2. In type 2 itself, some are working on prevention, some on prognosis, some on treatment. So we have divided the whole group. And I'm very privileged to represent India and Asia on this particular panel of Americans and European, in fact, only Indian there. And we have meetings almost every 2 weeks where we are reviewing what's happening. We are writing white papers. We are setting the research agenda and trying to take this field forward step by step. It's a very long process, but we hope it will actually launch in 2018, but only now it's picking up speed. And I'm sure in the next 2 to 3 years, you'll find a lot of developments coming as far as precision medicine and diabetes is concerned. In fact, precision diabetes itself, as I already said, now includes precision diagnosis because the diagnosis itself is based not just on one blood sugar or an A1C, you have to go much more than that. Precision therapeutics, because for different people, different therapeutic. Precision prevention. In fact, I am part of the precision type 2 diabetes prevention. We know diabetes can be prevented, but in who? And which is the best way to do it? Is there a subset of people in whom you can do it more cost effectively? All that has to be worked out. Precision treatment, precision prognostics, and precision monitoring. I wish I had time to show you all of these, but there is definite, for example, precision monitoring. Today we have a small sensor you wear on the arm. We use it in almost every person with diabetes now. And it will tell you the blood sugar levels minute to minute, which you can see on a cell phone. You can see it on your computer. You can see it on a reader. You can see it. And based on that, you can take your medicines, change your diet, change your exercise, and so on. So the whole field is really exploding, and a lot of work is happening in this field. But I'm going to limit myself to a few things in the interest of time. Let me talk about the role of precision medicine in type 2 diabetes. And type 1 diabetes is just evolving, where we are beginning to find why some people develop complications and others don't. The response to therapy, some people you give some tablet, it works very well, and others is totally no response, and side effects also, and the complications as well. Prediction of development of diabetes itself. Some have pre-diabetes, but they don't progress to diabetes. Some progress to diabetes in 6 months. Why is that? So these are all answers which you're trying to find. But I'm going to spend most of my time on monogenic diabetes, because this is the field where the clinician has actually started going to the genetic lab, and true translation from the bench to the bedside, bedside to the bench is happening. And I'll spend a little bit more time on that because that will be more exciting for you. And there I'll cover maturity onset diabetes of the young, or MODY, it's MODY, not MODI, and neonatal diabetes, onset of diabetes below 6 months of age. That means a newborn baby with diabetes. Can you imagine somebody 15 days old, 30 days old having diabetes? That's neonatal diabetes. That's where the genes are most needed. And then the opposite of that is congenital hypoglycemia. Newborn child presenting with hypoglycemia, all the time getting fits due to blood sugars going to 20, 10, and so on. I'm not going to talk about congenital hypoglycemia in interest of time, but I'll talk mostly about type 2 diabetes, MODY, and neonatal diabetes. Now, when you treat type 2 diabetes, we are already doing personalized medicine to some extent. For example, we look at the BMI. If you find somebody who's very thin, we might consider a tablet which also increases the weight. One of them is insulin, one of them is pioglitazone, one of them is sulfonylurea. You give the tablet, not only to control the sugar, but increases the weight. You might have somebody who's extremely obese. Now, you don't want to add a tablet to that, which is going to increase the weight. So they will give drugs today, which can very dramatically reduce the weight of the individual. SGLT2 drugs, GLP-1 receptor analog. Very recently, oral semaglutide has come. You can lose 15, 20 kilos, almost like as if you did bariatric surgery. The age of the person, an 80-year-old person and 30-year-old person, diabetes is not going to be treated in the same way. Somebody has renal failure, you're not going to give certain drugs. They're contraindicated. You can't even use them. Whereas the renal function is normally you're going to use it. So using simple clinical information, when needed, adding genetics, epigenetics, pharmacogenomics, we say that one drug A works better for some people, drug B for other people. Some respond neither to A and B, and they may need C. We use other markers like C-peptide, insulin resistance, and so on. Probability calculators are now coming in, and this is all part of the precision diabetes approach. About 2 years ago, a landmark paper from Sweden suggested that there are novel subgroups of type 2 diabetes. This was based on a very large data-driven cluster, artificial intelligence and machine learning, using 6 clinical variables. I won't go into the details, but they said that type 2 diabetes is not one disease. It's actually consists of 5 different types. And I slightly disagree with them because the first one, severe autoimmune diabetes, is not really type 2. So we didn't even consider it when we did it in our study. We dropped it because this is actually type 1. Okay. But these 4, the severe insulin deficient one, the severe insulin resistant one, the mild obesity related one without insulin resistance, and the mild age related one. These were the 4 subtypes that they described for the first time. And therefore, the world woke up and said, oh, hell, we have been treating all our type 2 diabetes as is one size fits all. And these are all having different characteristics. So the world really woke up. Now, just look at this. This is a severe insulin deficient variety, where anything to improve the insulin secretion should be what you should be giving. Here's insulin resistance. Anything to break the insulin resistance or insulin sensitizer is what you should be giving, and so on and so forth. This mild age-related diabetes comes in old age. We really don't have to worry about those people. Now, we wanted to ask the question, can this be applied to Indians? Now, you may say, why? Is it because of Me Too research you also want to do? They did something you also want to do? Not at all. We never do Me Too research because of waste of time. But because of 13 reasons why the type 2 diabetes in Indians is totally different from that in Caucasian. This has been shown by more than 200, 300 papers in the world, where our type of diabetes, type 2 diabetes, completely different from what you see in the West. Now, if you just sit in a clinic, if you show me some data, I'll tell you who's an Indian, who's a European, even by looking at things like gut microbiota. But you don't have to go that far. Age at onset, we get type 2 diabetes 20 years before they get. So their MARD and our MARD is completely different. We get it when you're much thinner. You don't have to be obese. Okay, insulin resistance, we were one of the first to show in a 1986 paper, Diabetologia, that Indians are more insulin resistant. More recently, we have shown that the beta cell function goes down very rapidly in our population. And that's why the thin Indian, most of them having that SID variety, the severe insulin resistant variety. And of course, there are many others. I won't belabor this point. NAFLD, which was mentioned, which you're working about, and then low vitamin D, which is there almost ubiquitous in Indians. Why is that? We don't know. Low vitamin B12, I mentioned the gut microbiota, and so on and so forth. One of the big factors is the low HDL, which should be of interest to you and could be one of the collaborations you should take up. We have the lowest good cholesterol or HDL cholesterol in the whole world. We still don't know why. We've been working on it for the last 15, 20 years. We've done some genetic studies, but it must be genetic. It cannot be because of the rice we eat or the chapati we eat and the carbohydrate we eat. There is some genetic factor which we are not able to find out. And this low HDL, we have the lowest HDL cholesterol in the whole world. Not the Chinese, not the Japanese, not the Europeans, not the black population. We have the lowest HDL. And that's one of the characteristics which we actually detected when we did our study trying to find out whether our types of diabetes are the same. And here is one paper where we looked at the collaboration with the University of Dundee. And I'm happy to tell you that just this morning, a couple of hours before I left home to come here, one of our papers has been accepted in Nature Medicine, where we are showing clear differences between Indians and the Scottish population. It's part of a Indo-Scotland program on precision medicine. And we are showing, using a cart tree approach, a novel approach, we are showing complete differences in the type 2 diabetes between the Caucasians and in the Indians. So this is one of our papers which we published on the novel subgroups of type 2 diabetes. Now the first population, the validation, the cohort came from the thing, but this is the cohort on which we first tested it. About 20,000 people across all our clinics, including we have clinics too, as you know, 2 in Calcutta. So across India, we have from these 500,000 patients, we selected those about 20,000 people newly diagnosed, and we tried to classify them into different subtypes. And then we reproduced it in our all India sample of the ICMR INDIAB study, where from every state of the country, we got samples. And using very simple variables, age at diagnosis, BMI, waist, HbA1c, triglycerides, and low HDL and HDL. Just using these, we did not even have genetics added, although we have the samples for genomic stored. Now we found 4 subgroups. Okay, of course we had dropped that SAID one, the autoimmune one, because that's really not type 2 diabetes. But when we tried to replicate what they had done, we found that 2 of them, the severe insulin deficient and the mild age-related diabetes, were the same as what the Scandinavians had shown. But there were 2 varieties. The combined insulin-resistant and deficient variety and the insulin-resistant obese diabetic, these 2 were not seen in the Scandinavian population. And guess what? This third variety, or the combined one, had the lowest HDL. So that is why it's not seen in the Scandinavian population. It's a unique population for us to study. And if you probably study the genomics of those people, we'll know why they have the low HDL concentrations. I'm just giving you a bird's eye view of what we have done. Now, you may say, why should you do all this clustering? Because the clustering actually determines, the type of cluster determines the type of complications that you'll get. And these are based on the longitudinal studies. So if you look at retinopathy, it is more common in the insulin deficient variety. Whereas if you look at the kidney disease, it is more common in the insulin resistant variety. And again, guess what? The only type which is prone to both is the third variety, which is prone to both retinopathy and nephropathy. And as I said, this group had not been described in the West. So we are beginning to understand why some people develop complications and others don't. Another thing which is of great interest is, if you take the ease of treatment, and we took HbA1c of 7%, reaching the goal, how easy is it for them to reach? Now, the easiest to reach, this is the percentage of people who reached it, was the MARD variety, because they have mild diabetes and they're age-related, they will easily reach. Guess what? The most difficult is the SID variety, because they have severe insulin deficiency. And we have insulin deficiency, you go and give them metformin. Remember, at this time, we didn't know what group they had. So we were following the standard thing, give them metformin, doesn't work, add sulfonylurea, doesn't work, give something else. That's how we were treating. And we found that it was very difficult to get them under control. And the next one was the third variety. It was also difficult because there's insulin deficiency there as well. So now we are beginning to understand why some patients are very easy to control, whereas others are not so easy to control. We have now developed a unique software. It's called the Diana software, or Diabetes Novel Subgroup. We just feed in the clinical details to the patient, and including the BMI, waist, HDL cholesterol. If you have C-peptide, you can put that in as well. And then the software will tell you that this particular patient whom you fed in has SID variety, severe insulin deficient variety. So, and it also tells you that the treatment, possible treatment for this patient can be a DPP-4 inhibitor or a sulfonylurea because they have insulin deficiency or insulin. And it also predicts the risk of developing complications. So to that extent, we have now gone, just by adding clinical data, artificial intelligence is able to tell us what is going to be the future of this particular patient. Now let me move on to type 1 diabetes. We are continuing our work on type 2 diabetes, but I'm just giving you a gist of it. Type 1 diabetes is still very early in precision diabetes, but we know that if you measure the C-peptide, in some, it's absent totally from day 1. In others, after 10 years also, there's some C-peptide maintained. We measure the GAD antibody, some are positive and some are negative. if you do a genetic risk score, a type 1 genetic risk score which has been developed now, you'll find them some being strongly positive and some being weakly positive. So we know that some have a very strong genetic background, others have a strong environmental background. But however, this is in its very early stages. Probably next time when I come to your institute, I'll be able to present more work on this. Is more work going on. Let me now move on in the interest of time to monogenic diabetes. So this is what is going to be very exciting for you. First, let me talk about maturity onset diabetes of the young, or MODY. MODY was described by Tarsal and Fyans when I was in my final year of medical school. I've already been working in this field for quite some years. Even in my first year, I joined and started doing research. When this paper was published, I jumped on it and I said, hey, this is something very interesting, because here are young people, because until then they said every young patient has type 1 diabetes or insulin-dependent diabetes. But these people in 75 itself said, no, here are people who have autosomal dominant inheritance. Their age at onset is below 25 years, but they have no ketosis, they have no beta cell autoimmunity, they need not take insulin at all for even more than 5 years. Insulin secretion is the main problem. They have no obesity, no insulin resistance, and it's a monogenic trait. Of course, when they said it's monogenic at that time, they didn't say it's monogenic. They didn't know it is monogenic. The gene for MODY was discovered only in 1993, almost 20 years later. It was a clinical diagnosis at the time, but by 1980, I had already started working on this, on the clinical side of it. Then the gene started getting discovered, and 14 different types of MODY were described. And everybody started reporting on MODY 1, MODY 2, MODY 3. Now, each one of this has a different clinical criteria. For example, MODY 2, if you diagnose a GCK mutation, they don't need treatment at all. You need not give them any tablet, no insulin, nothing. They will never progress in their lifetime. You just leave them alone, they'll be fine. If they have some diet control, that is good enough. MODY 1 and 3, if you have to treat them with sulfonylureas, and if you don't treat them with sulfonylureas, they won't respond. They are usually wrongly treated with insulin or some other drug or metformin, and they will not respond, and they can develop complications as well. There are similar clinical phenotypes of each of these. In fact, later on, last 3 or 4 years, ACMG criteria was mentioned. The ACMG, according to the ACMG, many of these are not MODY at all. So about 5 or 6 of these are probably MODY, and the rest have to be scrapped. They're not at all MODY. We are over-diagnosing MODY using the next-gen sequencing, and we have learned that now. So how do you diagnose MODY? Yes, by using the next-gen sequencing. We have developed our own panel of genes, which we are adding to it. We have a panel of about 80 genes now, which are added to that, cover all the monogenic forms of diabetes. Of course, we have separate publications on MODY 3, on MODY 1, MODY 2, MODY 5. We've been publishing in this for quite some time. This is another paper we published in BMC Medical Genetics, where we described 2 new MODY mutations for the first time in the world. It was a kind of a breakthrough paper, this one. And then in this paper, we actually reviewed the whole of MODY, which is published earlier last year, where we said which is actually MODY and which is not MODY, how the world should actually treat this, and which MODY should be reported, which are not clinically actionable and therefore need not be reported at all. All that has come. So you can see how precision diabetes is evolving. But you may ask me, this is all research, why bother about this as a clinician? Why are you so bothered about as a clinician? Just give them insulin and be done with it. Isn't it? As many of my colleagues, diabetologists will tell me, this guy is taking science too far, they say. Just give some insulin and be done with it, yaar. Make life very simple, they say. I'll tell you what will happen. Take the 16-year-old girl. She was thin. She presented with severe diabetes. HbA1c is 10.4. Now, anybody thin, 16 years old, HbA1c 10.4 is type 1 diabetes. Lifelong, they'll be asked to take 4 injections of insulin. And the girl was told, if you stop insulin, you'll die. That's what she was told. The parents were all upset, and they came running, crying to us and said, the child's future is gone. She can't get married, can't do this, can't do that. Can you think of anything else? I said, I don't know. We'll try. I don't know. It could be type 1, as you have been diagnosed to have. First thing we do, not complicated genomics. We take a pencil and paper and draw the family history. And this is something which I'd like to tell young students in your institute. Always draw a pedigree chart of any disease, whether it's thalassemia, doesn't matter what they have. Find out who else has in the family, because you have a rich source there to go back and collect more samples from those people. So this is our proband. And we found that on the mother's side, there was a lot of diabetes. On the father's side, you can see there's no diabetes. That's the uncle, aunt. There's no diabetes on the father's side. So even looking at this chart, we said it must have come from the mother. But then she could still have type 1, and the mother may have type 2, so we don't know. So we went ahead and first of all, we did the C-peptide. Now, C-peptide will be usually absent in type 1. And in MODY and in type 2, it doesn't go below a certain level, threshold. We now know what the threshold is. That's part of precision diabetes. And we showed that this girl had some insulin reserve. Then we did the GAD antibody test, zinc transporters. They're present in about 70–80% of type 1s. They were absent. And she had 3-generation transmission, as you saw. So we said, let's do the MODY genetic testing. Now, when we did the MODY genetic testing using the panel, we found that she had HNF1 alpha. This is MODY 3. And MODY 3 is a commonest form of MODY, not only in India, but also in the world. And this responds, and you can see the mutation there. And this type of diabetes responds to sulfonylureas. And so now we went back and collected all the family members, and every star that you see here is the individual who has the mutation. So by that time, what happened? This took some time because we were very slow in the early days. By the time, a sister also developed diabetes, and we found she also had the mutation. Mother had the mutation. Aunt had the mutation. Aunt's son had a mutation who was their age. And then few other aunts, and they all had the mutation and they had diabetes. The red means diabetes. The star means the mutation. So they all had MODY 3. And this is a novel mutation described for the first time from India. So we said, okay, this family is MODY 3. This girl has got it. She got it from her mother. All these aunts have got it. Now you can say that, for example, this person here, 2 of these children, one of them will get it. Whereas here, they will not get it because they don't have the disease. Here, there's one child, there's a 50% chance. And here, there are 2 children, one of them is going to get it. So the next job is to now go and identify all these children now and see who has the mutation and see whether we can do anything to prevent the diabetes from coming. So this is where from the clinic to the lab and then back to the clinic and back to the community actually. Now we have big teams of people going out to these MODY 3 families, identifying them. Some of them can be 1,000 miles away, but we send our teams there, meet the whole family, collect the sample. Some of them would have been wrongly treated. We then treat them back. So this is translation as its best. So patient is taken off insulin. We started on sulfonylurea. In fact, glibenclamide is the cheapest sulfonylurea on which is a few paisa it costs, much cheaper than insulin. She had excellent response. HbA1c came down to 6%, and she and her sister are still responding to sulfonylurea after several years. And so MODY genetic testing helped to avoid unnecessary lifelong insulin therapy in these patients. And I would put it to you that this is classical example of precision diabetes and true translation from the genomics lab to the clinical practice. And I wish we could do this for many more of our patients, not only with diabetes, but with other diseases as well. Let me now, if you thought now that was fascinating, oh my God, a 16-year-old girl taken off insulin. Now her mother and father are much happier because she just had to take a pill, a tablet, and the chance of getting married is much more than taking 4 times insulin per day. So her life, her family, all completely changed. Now wait till you hear about the next story, the story of neonatal diabetes, which is onset of diabetes below 6 months of age. So as I said, it's diagnosed in 6 months of age. After 6 months, it is less common. After 1 year, it never happens. We have had a few who are 9 months, 10 months, and so on, but never after first year of life. It is predominantly monogenic. There are 2 types. One is a transient variety or TNDM, where you get the diabetes when you're, say, 3 months old, but before the first birthday, it goes away. It may come back in adults in some people. You've seen it come back after 10, 20 years in some people. But permanent neonatal diabetes is much more common. I have only 2-3 cases of the transient one, but large numbers of the permanent one. The permanent one has a slightly different mutation, and that one will continue, okay? And imagine when a child is diagnosed with this, 3 months old, what will they give the child? They'll give the child insulin 3 times a day, okay? So let me talk about a child from Calcutta itself. It's not a made-up case, it's an actual case. This child has now grown up, by the way. She's now about 6 or 8 years old and doing extremely well. So when she was 3 months old, she was diagnosed to have diabetes. Actually, she was diagnosed to have 15 days after birth. And then first 2 months, she was treated with insulin. And then the parents just brought the child and said, something you do here, some tests to find out whether our baby has anything else. So she started on insulin. She's taking 14 units, which for a 3-month-old baby is quite large. 3.5 units per kg is a huge dose. At 4 injections per day, but her blood sugar is remaining between 300 to 400. Clearly, she was not responding to insulin. So she came to our center. Now, considering the age at onset, today it is mandatory. If anybody has diabetes below 6 months of age or even before 1 year of age, you should do genetic testing. I think it's a negligence if you don't do genetic testing. But who knows this? And how do we get this message across to the whole country? Okay, so we made a diagnosis of neonatal diabetes. and said that, okay, it should be sent for genetic testing. You may say, why should you do genetic testing? Why don't you just stop the insulin and start tablets? No, neonatal diabetes of several types, and only 2 or 3 of the common types respond. There are rare types of neonatal diabetes which will not respond to tablets, and child will die if you take the child off insulin. So without doing genetic testing, you cannot treat this child, period. Now, we did the Sanger sequencing because we know what to look for in this particular, this is done, of course, in our own clinical setting. And then we found that this child had a KCNJ11. Now, KCNJ11 and ABCC8, these are the 2 genes which will respond to sulfonylurea. So you can see this is the normal sequence, and this is the mutation here. And so this particular child had a glycine to valine mutation, KCNJ11 mutation. Now, this mutation responds to sulfonylurea. Okay, so you can stop insulin. So while the child was in hospital, what we did was we started lowering the dose of the insulin and started the child on glibenclamide. And the dose of the drugs are shown here. The green is the sulfonylurea. Slowly we started the sulfonylurea, and by day 5, what happened was you can see that the insulin dose shown in red. The blood sugars are 500 by the way. I'll show you the blood sugar in the next projection. So the insulin dose started coming down, coming down. By the 4th or the 5th day, insulin is withdrawn, and the child is now on only oral drug, very small dose of glibenclamide. And you can see the blood sugars initially not responding with insulin. After the sulfonylurea is introduced, near normal blood sugar level. It's a dramatic thing. When you see this, one of the most satisfying things to treat in diabetes. So by day 5, she stopped insulin, and the general condition also improved. Of course, this makes news. Genetic test helps a child from Calcutta who came, and the thing, but doctors say ignorance about disease is widespread. So we really have to get this message across to people. This is, her name is Ivana Das. The mother said, use her name, not an issue. Ivana, I think, is now about 7 or 8 years old, and she's doing extremely well just with tablets. And she's never needed insulin after that. And the parents, you can imagine what a dramatic thing it is. Now, that's not just one case. We are now building on case series after series. This is published about 10 years ago. First 35 cases, I think, of 33 cases of neonatal diabetes. And you can see here the dramatic response. Now, this is before the sulfonylurea treatment was in, this is in KCNJ and this is in ABCC8. You can see the A1C is very, very high, HbA1c, before the sulfonylurea was given when the child was on insulin. And you can see after the sulfonylurea was given, a dramatic response in the HbA1c as well as in the blood sugar. Blood sugar is completely normalized after giving the sulfonylurea and after stopping the insulin. So actually, insulin is a wrong treatment for this particular child. More recently, we have published a much larger series, about 181 cases. It's one of the largest series now, where we're able to find the mutation. Now, based on the mutation, the blood sugars are different. There are some children who come with 1,200 blood sugars, okay? And based on the type of mutation you have, the response is a little different. But ultimately, they all respond to the sulfonylureas. And now we have 4 years, 5 years follow-up of several of these children. Totally, we have about 500 children were referred to us, of which about 300 have neonatal diabetes, and they have been transferred to sulfonylurea. Now, if I mentioned that some genes don't respond, if the child has an insulin gene mutation, then the insulin gene itself is mutated. It's very uncommon. We reported another couple of cases recently, but that child will not respond to sulfonylurea. But thankfully, the majority of these children will have the KCNJ11 and the ABCC8. So if you look for these and you find it, it's completely life-changing for the child. Now, there are many genetic syndromes. Now, let's take a child who's developed at 1 year, 2 years, and you think that the child has type 1 diabetes. You do a genetic study and you find a mutation in the WRS, there is this particular gene, then it's Walcott-Rolison syndrome. Walcott-Rolison syndrome, the liver will get affected. Children with Walcott-Rolison syndrome don't live beyond 15 or 20 years of age. Into adulthood, it's never been reported. They'll develop skeletal abnormalities. They'll be short. And at the time when they come to the clinic, they won't know all this. They will not know. You're just going to treat them like type 1 diabetes. And it's not type 1 diabetes, it is WRS. DIDMO is another type where you have diabetes insipidus, DI, diabetes mellitus, optic atrophy, and deafness. So if you find this particular thing, the child can go deaf and can have optic atrophy. Okay, and you can predict that by using this. And these are not extremely rare things. You can find them. There's something called thiamine responsive megaloblastic anemia. You will find, or TRMA, you'll find anemia there. in a type 1 diabetic which is not responding to iron. You do the genetic test and you find the SLC gene here, mutation, and just give the child thiamine, B complex, and the diabetes goes away and the anemia goes away. It's quite dramatic. Some of these neonatal diabetes children have fits. They have mental retardation. They don't grow. They have neurological problems. The gene mutation takes care of the neurological problem as well. The child begins to grow, the fits stop, and the child's milestones develop. So it's a complete revolution as far as the treatment is concerned. I said I won't talk about congenital hypoglycemia. We're increasingly getting cases, 164 now. These are children who are repeatedly going into hypoglycemia. And then the surgeon says, you better get rid of the pancreas. And otherwise, the pancreas is secreting too much of insulin. So get rid of the pancreas, do subtotal pancreatectomy. Imagine in a 2-month-old child removing half the pancreas. Okay. Now, before that, if you find certain mutations now, and we published a large report with All India Institute of Medical Sciences, Delhi, about 40, 50 cases that referred to us. Now we know that there's a drug called diazoxide. If you give diazoxide, they will respond and the hypoglycemia goes away. But only some with certain mutation will respond to diazoxide. Otherwise, you can try octreotide, and there are other drugs to use. If none of them work, then they have to go for pancreatectomy. So instead of sending the child simply for pancreatectomy and screwing up the whole child's life, we can do the genetic testing and say, this child will respond to diazoxide, this child will respond to octreotide, and this child will not respond to anything. This is a child who have to go for surgery. And we have brought down the surgical rate very much. Hardly any child is now going for the surgery. And you can see these numbers are not small, 164, and the numbers are growing now. When to order monogenic diabetes testing? All children with diabetes or hypoglycemia with onset below 6 months of age has to have the genetic testing. And how to get this message across to the whole country is what I'm trying to do. And in fact, on March 4th, I'll show you that we're actually having a meeting on this because ICMR said to organize a meeting on this. All suspected type 1 diabetic, they're coming with type 1, but you find the C-peptide is present, like I showed you in that girl. C-peptide is present, GAD is absent, zinc transporter is absent. Is it really type 1? Just give the benefit of doubt. These tests are not so horribly expensive. You can do it free of cost also. We never charge for our neonatal diabetes, is completely free. They're not done 1 rupee. For all those who cannot afford, we do it free. They can afford, rich person come, we'll say we've got a genetic, you want to pay for it, that will subsidize someone else. So it's not done for commercial purposes at all. Then, if you have somebody who is treating as type 2 diabetes, okay, it's not fitting in with that kind of SID and things like that. They're lean, they have no acanthosis nigricans. Then see whether they have MODY, because MODY responds to sulfonylurea. Type 2 diabetes responds better to something like the type 2 diabetes responds to metformin, whereas MODY responds better to sulfonylurea. So precision diabetes is slowly but steadily coming in. Now, we have become a national center now for monogenic diabetes testing. So these are all the places, including all the medical colleges, PJ, Chandigarh, AIMS, and many other. Of course, from Calcutta, we get lots of cases, and they are referring to us. We give them the report in 2 to 3 weeks' time, if possible, and tell them what to do as far as the treatment is concerned. We also set up what's called as the Monogenic Diabetes Registry of India. And if you just type www.monogenicdiabetes.in, you will find how to send the blood samples and how to fill up the forms, consent form. All this we collect through the registry. So I'd like to conclude, ladies and gentlemen, by saying that precision diabetes is slowly coming of age. It can be applied to all forms of diabetes, and I'm sure in 5 years' time, we'll be talking of precision type 1 diabetes, precision fibrocalcitic, precision gestational. In fact, the whole group studying gestational diabetes, but they are not, that's a very complex thing as well. It's not one disease. With respect to type 2 diabetes, 4 clusters are seen in South Asians, that's Indians. 2 are the same as the Scandinavian cluster, but 2 are unique to our population, IROD and SIRT. Study of monogenic diabetes has helped many children with neonatal diabetes and youth with MODY to go off insulin completely. Precision diagnosis helps to offer precision treatment and thereby improve the quality of life. All children with diabetes diagnosed before 6 months of age must undergo genetic testing. Neonatal diabetes, the ABCC8 and KCNJ11 mutation can be successfully transferred to sulfonylurea from insulin. Many of them may be able to stop insulin injections completely. This represents a miracle of sorts for the child and the family, because once you diagnose type 1 diabetes, for the rest of the life, that child has to take 4 injections per day. or use a pump or something else. We don't have any other form of treatment. I'd like to end by thanking Dr. Radha Venkateshan, who I believe is listening in, and our team. I hope all of them are on attending this meeting. They've done a phenomenal job. I think Radha joined us about 20 years ago, and sometime a little later than that, Partho came and visited our lab and sanctioned some of the equipments. And it's been very difficult for a private center to set up and get. Every time we ask an equipment, it will be turned down, and even to get basic equipment is extremely difficult for us. But with all those challenges, I think over 100 publications from her group, 13 people have finished PhD. And we have a large group even now working on it, trying to improve the lives of people with type 1 diabetes. This is a meeting I mentioned on 4th March. We have it in the evening from 4:30 to 9. And the whole focus is only on monogenic diabetes and congenital hyperinsulinism with hypoglycemia, and trying to explain what is this to pediatricians and to others. So we're trying to call pediatric endocrinologists, pediatricians, other endocrinologists, and others who may likely treat this. And so that many more such children in India, we can try to help as what we have done. Jagdish Chandra Bose, J.C. Bose, said that when one dedicates himself wholly for a great cause, the closed doors shall open. He didn't say it may open. He said it shall open, and the seemingly impossible will become possible for him. Partho, this is what you have done. You had an idea, and you said we will build a national institute of medical genomics, and you have done it. And you have a great team to take this forward. You're still associating yourself with it, and you must continue to guide the younger team as they take over. As Dr. Soumitra Das was saying, it's only in its teenage, but then teenage has its challenges as well as opportunities before they fully mature into an adult. And I think your institute will make much greater contributions in the years to come and bring glory to India, and that's what J.C. Bose had said. And I look forward to collaborating with you in some way. You have seen my interest, my passion, you have seen, and how you can help us and how we can work together so that we make a mark on diabetes. I saw here and there peripherally diabetes was coming in some of your presentations, but I didn't see a focused attention on that. Maybe you should make it one of your theme areas, and we would be happy to partner with you in a very big way, and thereby make India proud. Just as you would like to make a mark, we would also like to serve India. Jai Hind.
Thank you, sir, for the illuminating. So with this, to the ending session for Institute Day celebration. The NIBMG will start at 2 p.m. So once again, I would like to take this opportunity to thank our distinguished guests.
Is Professor Pathamajita here? Or I didn't.
Yes, sir. He's on the thing. I am trying to connect him and see if he can.
Just to say hello, nothing else. So while they're connecting him, I think I see a great opportunity for collaboration, and would love to come back sometime later this year and spend a day at your institute, probably bring some of my team members and see the work that you're doing. And likewise, I would like you all to come and see what we are doing, and you can guide us and handhold us how we can take our work. What I didn't present is hi Partho. I think you're muted, Partho.
You are mute.
Can you unmute?
Yes, you are getting him, sir. We are getting him online. Just a second, a few seconds.
Okay.
So your talk was wonderful, and we are very excited to hear your interest to work with us. Definitely, we'll take this up.
Thank you.
Thank you. So they're still muted.
No, actually there is a technical. So Bikram is working out. He's,
If there's a problem, then that's fine.
no, he's there. He's there. He's joining. He's again coming back. He will come back again. He's. Yeah, he's there. Oh, Hi Mohan, can you see me or hear me?
I can hear you.
Yeah, so I was, the controller had kept me off, so you could not see me, or I couldn't talk to you. But I was sending you a WhatsApp message saying that, this must be an eye opener for all our students and for my younger colleagues in the institute. I think this is translational genomics at its very best. Yeah, and of course, you are a fantastic speaker and a very persuasive speaker with case studies and all of this. So we now know what genomics can do in order to translate to human health. Oftentimes we are very far away from the bedside. We don't really understand, perceive what genomics can do to human health. But your talk was an eye opener, and I'm extremely grateful that you have kindly come on and given this talk. Thank you so much.
Thank you, Partho. And hopefully we can work together and do something more, take it to the next level. Thank you so much.
Yeah, okay.
Congratulations again for the great institute that you have built. And thank you, Arindam, Anupam.
Thank you.
Keep up the good work.
Thank you, sir. We'd like to see you have your footfall in the campus very soon.
Thank you. Bye-bye.
Thank you. So yeah, so now we come to the end of this session, and I would like to take this opportunity once again to thank our distinguished guests, all dignitaries present, and all the members of the NIBMG fraternity who actively participate in this event. So with this note and with due permission from all the dignitaries present, I would like to close this session. Thank you all. Have a great day.